The overall goal of this methodology is to synthesize suitable X-ray monocrystals of 3,5-lutidine N-Oxide dehydrate in shorter reaction time using inexpensive and easily accessible reagents to yield a novel solvated supramolecular structure.
This method can help answer key questions in the synthetic organic and inorganic chemistry fields, such as how to synthesize novel aromatic compounds, heterocyclic compounds, and pyridine derivatives. The main advantage of this technique is that it uses solvents and materials that are more accessible and generally found in any research laboratory. We first had the idea for this method when we were in search of an optimal route to obtain 3,5-lutidine N-Oxide as an intermediate of 2-amino-pyridine 3,5-dicarboxylic acid.
First, place an open 100 milliliter round-bottom flask containing a magnetic stir bar on a magnetic stir plate in a fume hood. Add 29.8 milliliters of glacial acetic acid, 5.82 milliliters of 3,5-dimethylpyridine, and 5 milliliters of 35% hydrogen peroxide to the flask. Stir the reaction mixture at an inner temperature of 80 degrees Celsius for 5 hours. After the reaction is complete, cool the flask to 24 degrees Celsius with ice. Once cooled,